of Telangana Chambers of Commerce and Industry, in collaboration with Cloud Computing Innovation Council of India, CCICI, at FTCCI, we proudly carry our 105-year-old legacy of selfless service towards empowering industries and trade practices in the entire state of Telangana. And today's webinar on application modernization powered by 5G and Edge is one such effort in the same direction. Before we proceed, I would like to show a small clip of FTCCI and its journey so far.
(1917), the year when a dedicated organization, the Deccan Chamber of Commerce, was formed to encourage trade and commerce activities. The historical journey of the organization has witnessed great transformation as per the changing needs of the industry and businesses. The Federation of Telangana Chambers of Commerce and Industry, FTCCI, a legacy of excellence, voice of the industry, representing interests of over 25,000 businesses of all sizes, sectors and regions, is empowering industry and trade of Telangana state. A world leader in pharma, a global hub for vaccine, home to all major MNCs, leader in IT exports, and emerging first stop of India. FTCCI advocates a pro-business environment, caters to the needs of MSMEs, budding entrepreneurs, and traders through its advisory services in taxation, market information, industry-related issues, B2B connection. The Chamber has its nominees in the state-level advisory committees to help drive business productivity. FTCCI aids in providing certificate of origin for exporters, issues visa recommendation for business travels. The Federation imparts job skills through its dedicated skill center. It has adopted 14 government ITIs to improve the employability of students. With a uniquely global perspective, the FTCCI events reach a highly engaged audience, policymakers and stakeholders aiming towards Atmanirbhar Bharat.
FTCCI to work with government, tell us and guide us कि हम लोग क्या कर सकते हैं to remain competitive, to remain better than our competition. FTCCI for joining us, and I thank the office bearers of FTCCI for inviting me. Jai Telangana, Jai Hind.
Come and be a part of this dynamic and proactive organization. Together, let's realize the vision for a progressive future.
So once again, I would like to welcome you all to this wonderful event that we have today. And with this, I would like to call on Mr. K. Mohan Raidu, the chair of ICT committee, to open the webinar.
Thank you, Vishal. Have you started recording, please?
Yes.
Okay. I welcome Mr. Prakash also, Mr. Prakash Ramchandran.
Hi.
Yeah, hi. I'm very happy to welcome you all to this webinar on application modernization powered by 5G and Edge. I would like to extend a warm welcome to our chief guest, Dr. Gautam Mahapatra, the Technology Director for Cybernetics at DRDO. Our expert speakers, Mr. Prakash Ramchandran, Executive Secretary of the EOTF, and Mr. Sesha Venkata, the General Manager and Global Head of Wipro's Virtual Desk for Cloud and Infrastructure Services. So they will be speaking to us. And this webinar is being organized by FTCCI, Federation of Telangana Chambers of Commerce and Industry, in collaboration with CCICI, CCICI is Cloud Computing Innovation Council of India. And it is a premier national forum on cloud computing. The founder members include Mr. Chris Gopalakrishnan, the founder of Infosys. I'm also a part of it, and almost all of us on the panel are part of the CCICI also. We provide policy guidelines and standards to Government of India and several state governments and enterprises across the country. Today's event is very special because all the speakers, myself and co-chair Bala, are associated for years in a good number of professional forums like CSI, CCICI, FTCCI, and Internet Society, and Hyderabad chapter, things like that. So it's a very special occasion in which we are all engaged together. So this application modernization is the practice of updating older software for newer computing approaches, including newer languages, frameworks, and infrastructure platforms. Most enterprises have significant investments in their existing application portfolio from both financial and operational standpoint. Some companies are willing to simply retire these applications and start afresh. The costs, the productivity losses, and the issues are too great. Therefore, application modernization is the most sensible way for many enterprises to realize the advantage of newer software platforms, tools, architecture, libraries, and frameworks. The modernization of apps made possible by 5G and edge computing provides a paradigm shift in the way services are provided to customers. Applications can be updated to offer a seamless and dependable experience for consumers by embracing the dispersed nature of edge computing and the reduced latency of 5G networks. High bandwidth material such as the streaming movies can be delivered by 5G networks, while edge computing enables the offloading of computer resources closer to the end user for better performance and dependability. Applications ranging from gaming to industrial automation will be powered by these technologies, and they will offer a better user experience that can scale to meet the needs of the digital age. This is a brief note about the application modernization, and today's distinguished speakers will enlighten us more about the topic. Thank you.
Thank you.
Now, one second. I will introduce the chief guest of the day, Dr. Gautam Mahapatra. Dr. Gautam Mahapatra is a distinguished graduate of IIT Dhanbad. He was awarded President Gold Medal, Best Student Award of the Institute and University Blue for his excellence in academics, sports, and co-curricular activities, and for demonstrating a high degree of moral and righteousness. In 1992, he secured the first rank in All India CSIR examination and received CSIR fellowship. A brilliant scholar and a researcher whose seminal project brought him Dr. Hari Narayan Medal by MGGI at a very young age. Dr. Gautam Mahapatra has 30 plus years of research and project implementation experience in IT and computer science in defense R&D organization. He's a director grade scientist at DRDO. As Technology Director IT, he has led all IT initiatives of Research Center Imarat, RCI, a premier R&D laboratory of DRDO. He has steered the vision of IT enablement of the R&D organization. His expertise encompasses in design and development of enterprise class IT systems, fault-tolerant systems, cyber defense and analytics. Presently, he is the Technology Director, Cybernetics, and is responsible for the development of state-of-art technologies in the field of network-centric warfare, mission planning systems, and quantum computing. He has published many research papers and received many awards. To name a few, Nihilant Award of Excellence in E-Governance, Hall of Fame, IT Person of the Year 2015, and Best CIO of the Year 2016. He is associated with many professional bodies like IEEE, Indian Science Congress Association, CRSI, etc. He is fellow of CSI, IETE, and the Institute of Engineers. I present to you Dr. Gautam Mahapatra. Thank you. I invite Dr. Gautam Mahapatra to address us. Thank you.
So, namaskar and good afternoon.
Very good.
So, ladies and gentlemen, participant, and it is really my pride and honor to be part of this webinar on a very relevant topic, actually, application modernization powered by 5G and edge in virtual mode. So, I thank FTCCI, their office bearer, and their collaborating organization, that Cloud Innovation Council, for patronizing such events with an objective to contribute for the economic development of the Telangana states. Really, it is a very commendable initiative by these two bodies. And I must congratulate the ICT committee chairman, Mr. Mohan Raidu, and Mr. Bala for hosting regular events on state-of-art disruptive IT technology for the benefits of the community. Okay, I have seen that last couple of years how they have put their efforts in disseminating the knowledge in the field of IT technology, which is really commendable. I also express my gratitude and appreciation to our expert speakers, Mr. Prakash Ramchandran and Mr. Sesu Venkata. So they are really very good in this field, and they are practicing the subject on this particular area. So really, I'm very glad to be associated with them. So actually, if you see that this discontinuous technology has resulted the industrial revolution for us. So see, if we go back, we'll find that we started with agriculture era. Humanity started with agriculture era. Then it came to the industrial era. The industrial revolution marks a major turning point in the history. Almost every aspect of our daily life was influenced in some way by industrial revolution. Okay, see, this industrial revolution, if we again drill down, you will find that there are two distinct aspects. The earlier industrial revolution, it was steam-powered technology. It was enabled by the steam power. But the next industrial revolution, it was characterized by the electric powered motorization technologies. See, why I am mentioning this thing is that, see, if these last three revolution, if you see, we have the humanity has taken a very distinct jump, very distinct achievement by this revolution. Actually, at present also we are going through, I should say, this is the third or fourth revolution, that is the digital revolution. Okay, that means I want to say the most recent one by the digitization of societal systems due to IT, ITS, and ICT. And we have just started our journey in post-industrial digital age and knowledge-based network society. So I want to highlight that we have already entered in the digital revolution journey. Okay. Now, see, I am very, very excited that ICT committee has chosen such a relevant topic. Why, this? See, if our society has to be digitized, may it be professionally, may it be personal life or in business life, then effective digitization has to happen. Okay, that if for effective digitization to happen in our society, age level computing is very important. See, let us say, if we analyze, see, when we started our digital revolution or digital journey, rather we say, see, what we did is entire computing was taken back to the data center. Is it not?
Yeah.
See, because we wanted to develop a fort. Okay. See, we cannot build n number of fort everywhere. Okay. So we have taken baby step in digital revolution. So we wanted to have couple of fort in form of robust data center where all applications were consolidated. Okay, that has also played its role in our journey, because through that data center we gave very scalable application, very stable application, okay, secure application. So that I should show that in IT journey, that fourth era, maybe it is elapsing. Okay, we are now taking the journey from fort to the when we are coming out from the fort and try to approach the end devices, end user, where data is getting generated. Okay, so I would frame like this: for digital revolution of our society, we need to think of a computing paradigm which can take the computing nearest to the user at the edge of the network, where processing of data can happen, where data is getting generated, so that we can process large chunk of data with great speed and in near real time. And in fact, this paradigm, actually we are rebranding, or IT fraternity has rebranded as a edge computing. Okay. See, this edge computing, it has already pervaded, knowingly or unknowingly, we have already adopted and people are adopting. See, this edge computing has brought many intelligent application areas and given great benefit to our society. Okay, like say digital health, autonomous car, telemedicine, fintech, public safety, etc., where knowingly or unknowingly we have adopted some extent of edge computing. Already we have adopted. Okay, so this this probably it will get a push. This edge computing will get a push if we properly put it in a framework and then give proper thrust to it. Then it will really develop. And in my opinion, I feel that if digitization of the society in terms of industry or personal life or social life, it has to happen, then edge computing has to pervade everywhere. Okay, of course, each technology is like a double-edged sword. It will have advantage, disadvantage. We will come back to the latter. But let us see that how that edge computing we have adopted. For example, say the digital health. Okay, each of us now wear the smartwatches. Okay, it picks up the various signals from our body, say like say blood pressure, then oxygen level in the blood, etc., heartbeat. Okay, and those are processed in the tiny devices in our watch, and some sort of result it shows either in the watch, or more details we can get it in the apps in the mobile. So this is also a part of edge computing. See, I have some connect with the people, with the researchers, those who are working on the digital health area. I have found that researchers are prototyping health sensors that are tiny, wireless, very low power, intelligent, bio-implantable, or it is wearable. That type of sensors they are working. This is a totally multidisciplinary field. And many of these researchers, what they are trying to do is see their thought process are very, very disruptive. What they are thinking is they are trying to develop a health grid network they want to find. So, as for example, suppose all of us are wearing now smartwatch. So they are thinking that they will pick all the important health aspects, and first this watch will sync with your mobile, and then this mobile will sync with the data center, and this health parameter will be stored there, and that is not their end objective. They want, you see, say suppose this COVID type of pandemic happened. Okay, so if this type of grid is available, then this data will be shared to the government agency, to the doctors, to the healthcare service provider, to the social workers, so that see we can see that that if there is any pandemic in our society, or say suppose see in particular people have seen that particular gene, some certain kind of heart diseases develop. Okay, whether so that kind of investigation they want to do through this. In this example, you see our watch is nothing but the edge device, and our mobile maybe at the fog layer, and that at this data center layer where they are putting the all health records, that could be the your cloud layer. Okay, see similarly another good example is that ADAS, advanced driver assistance system, okay, which is now presently available in most costly car, which general people cannot afford probably, because now all the cars are becoming autonomous, intelligent, all these things are happening. See, I like to highlight here that intelligent word, the word intelligent, because AI and ML, these things actually there is one discontinuous technology is coming. I'll mention at the end how the compute infrastructure is going to change. We have certain working level experience also that I like to highlight. But here the point to address is that see this ADAS system which is an autonomous system, software-based system, which basically what it does is these cars maneuver itself to keep itself in the track so that accident doesn't happen. See, presently, if you see the statistics, almost every year 1.5 lakhs people die because of the accident, and most of the cases the accidents happens because of the human error. Okay, so government is manipulating whether they can or they are thinking that whether they can make it mandatory that ADAS feature should be in every passenger segment car. Okay, so that the accident level can be reduced. So here you think of this, see, if this edge computing is not adopted properly, suppose it depends on some layer which is not on board the sensor, suppose some resources which is not on board the car, then ADAS cannot happen properly. Okay. So this shows that this example shows that really if society has to get benefited in a very drastic way, then edge computing probably is the order of the day. Okay, so actually now the problem is that there are certain issues with this type of edge computing, at least in the pageant form. There are many challenges with respect to its architecture, infrastructure, deployment, security. There are many challenges. Those challenges we have to resolve when we are going ahead for the edge computing. See, first challenge is, see, edge devices, like say IoT devices. These are very tiny, small, with limited resources. So it has very small power. It has very small storage. The compute, the processor is very small. Okay, we probably cannot run very large application or a large database or even normal database in the same format. We cannot run on those kind of edge devices. And the security is also a challenge. See, now BYOD has come. Okay, now if we don't take the proper security mechanism in the place, then this can create disaster for the organization. Now, I think Mr. Sesu will be speaking on this, so I'll not go into that. Okay, and then see, this is one problem. So evolving edge application should be commensurating with the resources which are available at the edge level devices. That has to be taken care. Whatever, we have to scale the application, we have to build the applications as per the resource available on the edge devices. Okay, so edge computing, in my opinion, edge computing architecture will continue to depend on the other two layers, that is fog layers and the cloud layers. Okay, these two layers, it has to depend on this for time to come. And here, one important thing is that this, see, that's why I was telling this topic is very relevant, because they have highlighted this thing in the heading itself, in the topic itself. This 5G will play a great role connecting the edge devices with the fog layer, even with the cloud layer. Okay. Achha, there are certain trends already happening. See, first trend is that, see, now, you know, these people, see, one day will come, there will be fog data center in a suitcase. Okay, now multi-core processors are available in the market. Okay, so, and 5G, 6G, it is coming into the, it will come, some high bandwidth, these things, Gs are coming. So see, so network volume will sink. So this fog data center, it will be very closer to the user. In fact, if you see that Netflix has started, they instead of one big global data center, they're now distributing their data center towards the to the locality. That is their concept. So actually, see, one good business model will be in the coming futures. See, what will happen is, as this edge computing will evolve in terms of its standard performance and other things. So suitcase-based data centers, not a very small data center, that will be a reality, which will be used at the fog level. I feel so. Okay. So that is one thing. Then 5G here. 5G another issue is there. I should not be issue other than bandwidth also. See, 5G, no, it is based on SDN, software defined network. Okay, it is very easy to authenticate with the appliance, or they say with mobile. See, 5G we can make a default setting which will authenticate the device, but user level authentication you have to inbuilt in the application. So that is not there in the see, 5G has eased out a lot of difficulties. Okay, but still, see, the moment you are thinking about the secure edge computing, in the application layer, you have to build up that user level authentication. Okay. Then see, another aspect I must highlight. See, this type of edge computing, it will have the distributed database. See, n number of sensors, they are collecting data, they are processing data. So it has to be a IoT friendly distributed database. Some of them has come like InfluxDB, SQLite, Apache Cassandra. Those are available in the market for developing edge apps, and it has started coming. But their main feature would be, see, if you see in our real life, Mr. Sesu will agree that in our data center, large data center, if you see, all the database servers are vertically scalable. Okay, but it will be slightly different. These database should be horizontally scalable. Okay. So vertically scalable database means, what I want to say is, say suppose I have 100 users database server. Okay. Say tomorrow another say 75 users are getting added, or 50 users are getting added. Then I have to say, suppose earlier one database server was having 2 CPU. I have to have a 4 CPU server. One 4 CPU server. This 2 CPU server I cannot use because it is a vertically scalable. Okay. So my 2 CPU server I have to remove and put a 4 CPU server. But in horizontal scalable case, what happened is that 2 CPU server will exist as a database server, and with that we'll put another 2 CPU servers. Basically, the way application servers are scaled, same way database server will be scaled. Okay. These are the features. These are the features are coming in the distributed database, which are actually required for the growth of edge computing. Okay, then see, now this is about the database. Another point, just I'll highlight that architecture for stateful edge application. The several key points it has to address. That here also, no, we have to be very specific about the identifying the workload, and those workloads should be programmed on the edge device accordingly. say, suppose some edge device will be streaming data. Some edge device will be streaming data with analytics, say a camera. Okay, same programming, same thing we cannot use. Your programming has to be edge device character dependent, work dependent. Okay, then scaling requirement. See, it has to be scaled. See, I'm forgetting the technical term for that. Okay, see, what happened, this this kind of, especially in edge computing, what happened? See, the traditionally, say, kind of ERP application or monolithic application, what happened is there's a module-based structure. Okay, now say, suppose, say 500 users are using. If somewhere that function gets stuck, say maybe 200 users are there online, it will be thrown out. If anybody can remind that term, actually, I'm forgetting that. I'm not getting that term. So, but in this, see, Netflix.
Power management. Auto scaling and power management.
Yes. So, see, if you see that, say, even Netflix, suppose 3 of us or all of us seeing a same movie at the same time. Suppose in my TV there is some problem, hardware there is some problem, that movie gets stuck, but all other people will still continue to have the same movie. So that type of architecture will come into the edge level. It will have the lot of fault tolerance inbuilt. So there are some platform coming also in this. See, another aspect is, see, all the
Dr. Gautam, time is running, so other speakers are there.
Okay, so basically what is happening is that all the 3 giants like Microsoft, Google, Amazon, they have started providing those services. And specifically, I like to see, recently we use certain kind of platform like this, say Clearblade, Eclipse, iFog. These are the all edge computing platform which coming up. Okay, now I'll just, to conclude this, I like to two important aspects which are discontinuous technology. See, first, this aspect is the future of the computing will be radically different in terms of hardware. See, so long we understand digital, now analog computer is coming in place, because you can solve AI much faster way on analog computer than a digital computer. Suppose you are solving a 10th order differential equation using digital computer, it will be a hopeless situation compared to a analog computer. Okay, and this analog computer, actually it is a special purpose computer. Say suppose you have some AI application. Say I am guiding a missile through some AI guidance algorithm, and I am using the analog chips. Okay, and say I have a statistics that suppose say 25 trillion math operation you want to do in an analog chip, it will just consume 3 watts power. Whereas same thing I wanted to do on a digital chip, it will take 150 to 100 watts power. Can you imagine the size of the chip, how it will increase? Here the disadvantage is that analog, it is a single purpose. This computer will be, analog computer will be a single purpose, no repeatable, and it will give the inexact value, not the exact value. Okay, so actually at the edge layer, whatever computing is going to come, some of them will be of analog computer. That message I wanted to give. Okay, not only analog, it can be hybrid also. Say suppose it doing 2 jobs. One, it is say AI something it is doing, it will be on analog chip, and then on that basis it is taking some analytics that will be on digital chips. So that type of hybrid scenario will be there. Then see another aspect which defense is struggling. Actually, the how quantum computing will raise the cyber security aspects. See, because qubits are much faster than the bits. I'm not going into the details. See, all the existing cryptography, it will break easily by the quantum computers. Okay, say our banking operation, it will be open. You can think of that type of scenario. Okay, so in fact, another inputs that see, quantum cryptography is very poor for wireless. We have to now no standard has come up. So basically, what we have to do, even say suppose India cannot develop quantum computers the way other developed nation has done. But one thing we should not miss, that is the quantum resistant algorithm. So quantum safe algorithm to be introduced at the application level. So with this, I'll stop.
Gautam, I think we are running out of time because
I'm closing these things. With this,
yes.
I'll stop.
Yeah.
And then this next two talks are very interesting. And thank you for your time.
Please share in an article we will publish in our magazine. We have a fortnightly magazine. We will carry it out in our magazine. Thank you, Gautam, Dr. Gautam Mahapatra.
Yeah.
Dr. Gautam Mahapatra is a pride of us, our Hyderabad. He's doing wonders in DRDO. And for our CSI, he is a wonderful asset for all of us. Thank you, Dr. Gautam.
Thank
Now,
you.
now we have other two speakers, Mr. Prakash Ramchandran and Mr. Seshu Venkata. They will be speaking, and then we'll have a question answer session followed by a vote of thanks by Bala. Now I invite our Vishal, our this director, assistant director, to introduce Mr. Prakash Ramchandran.
Now I would like to invite Mr. Prakash Ramachandran, Executive Secretary at EOTF, to share some light on the topic. Mr. Prakash has 4 decades of telco ICT experience with MSEE from IIT Bombay. He is the Executive Secretary for Emerging Open Tech Foundation India and was an Indeed member board of directors OpenStack/Open Infra Foundation, senior member of IEEE, LFX PC chair for China Summit, and has been a veteran consultant on various industry solutions. Has served with companies like Dell, Hawaii Tech, AT&T Mobility, Intellisys, Tandem, GTE, Macrodata Consultants, and has served as a professor for Mumbai University IDM. Is an SME in Edge and Cloud, Edge Cloud and 5G, and a regular speaker of OpenStack, OPNFV, 3GPP forums globally. So, Mr. Prakash Ramachandran, welcome to you. Welcome to the webinar, and I would request you to please shed some light on the topic.
And this topic will be?
Hello. Yes, sir. Sorry.
Yeah. You have his topic?
Yes. So Mr. Prakash Ramachandran will be speaking on app first or infra first, the dilemma of edge computing.
Thank you, Vishal. Over to Mr. Prakash Ramchandran. You're muted, Mr. Prakash.
Yeah, can you hear me?
Yeah, now we can hear. Yes.
First of all, thank you everyone for the opportunity to present to the FPK and FTCCI here at Hyderabad. What should I say? I don't know. Dhanyawadalu, as far as I know, for all the effort, and we definitely want Telangana to go ahead and forge ahead. And you have some of the talents which we must recognize are top notch. and nothing moves without Hyderabad and Secunderabad. So both Telangana and Andhra wish you a very great success. And with that, I know I have a lot of preceding speakers and hardly I could remember the names, but I acknowledge all the things they have brought and built up to a stage where I can deliver my presentation very easily now because they have gone through the details. I'll give you a bird's eye view from first at the top, then go down. So first you remember that applications were there forever, whether they were monolithic, whether they were client server, whether they were free tier, or whether they were ASP, that is application service provider as hosted, or then eventually as uh, cloud native, edge native. So there is an infinitum in that application delivery. So applications, if you take as the first thing, then the question is, where is it hosted? What resources does it need? If it is in the cloud, fantastic, resources infinite, unlimited as it appears to it, and it can freak out. You can do any application any way you want. You don't care really because you got this. But when you move the application, instead of being at a distance, which is the cloud takes on an average at least with the latest 4G, I would not put 5G latest, little bit 5G is still coming, but with the 4G it used to be 20 millisecond round trip minimum. So what it means is, if what is humans capacity to react? 5 milliseconds. If you do something interactive, you have to, if I say something, you have to interact, means you have to interact in 5 milliseconds. So there is no scope for that interaction as far as 4G is concerned. Yes, it is there now. In real time depends on the application. Some application you can wait forever, some application you can't. So applications point of view, the real time application is different for different applications. If I do an online reservation, if I book and somebody else books while I am holding it, the database lock is not applied, or I applied a little too late, that's it. You lose the opportunity to fly. So what it means is, or if you have a bank account and you are debiting and trading, one happens, the other doesn't happen. You get charged, but you don't get delivered to the party so then you're again in trouble. So therefore, real time for financial transaction may be different from healthcare, may be different for different vertical. Agriculture, if I put a water 1 minute late or 10 minutes late, doesn't make difference, and then it's okay. So 10 minutes is real time. So real time may be 1 millisecond, 5 millisecond, 20 millisecond. When you talk of edge computing, we are always looking for what is the real time and what is near real. And any application that cannot satisfy that, that is, if you take a sample and process and you take another sample before that, you don't finish, then your real time is gone. So that means you have to aggregate. Even if you aggregate, say, 10 samples and then process and then take an average of that, and then you have to process within 10 samples. So what it means is, any application that requires a real-time response, whether it is near real-time, or can be real-time in the sense of 10 minutes, every application needs some kind of resource. At the cloud, you could do infinite resource was there, you can allocate anything. So it gives an impression that everything is possible. But when it comes to cloud, as my previous speaker said, constraint can be in terms of infrastructure, can be in terms of power, because in data center there are only three: location, power, and the what you call the capability to process. So basically infrastructure, that is. So if you have the data center, which is equivalent of a location for your application, and that happens to be near to you, like you are in Secunderabad and you have Tank Bund close by, you are in Hyderabad and you have the railway station thereby, and some data center is there, then that is near to you. But you are going to go and access somewhere in New York, that's not near to you. So that is the cloud. cloud can be in New York, edge can be in Hyderabad. So what it means is there is a process involved as to how the applications are implemented, whether it's a agri-tech, whether it's a automation, autonomous vehicles, as mentioned by previous speakers, then it could be a drone application, it could be a UAV, it could be a XRMR, AR, XRMR. It could be industrial application, ultra low latency. So depending on the application, how much is real time? So in real estate, we say location, location, location. If you get at the right location, you are good and you can make good living or good earning, whatever. Same way, in the case of edge, it is latency, latency, and latency. If you get the latency right for the application, then that infrastructure is the one which is good for the application. So the dilemma here is whether I should look at the application first or should I look at the infrastructure? So when did the edge computing come into actual? There was a seminal paper by Professor Satya Mahadevan of Carnegie Mellon University. He floated out something called as cloudlet. Now, when you say let means small, cloudlet means small cloud. Small cloud means he perceived that there is a small VM virtual machine, because VM was popular from 2000 when the VMware came, and VM, everybody knows that virtualization is the way. So if you have a virtual machine and if you can put an application to it, then that virtual machine we can move anywhere to anywhere, whether it is in the cloud or whether it is in the cloudlet at the edge. So his seminal paper kicked off a lot of activity. Everybody started, oh, I can do with image. I just keep the image of the application, because at the end of the day, what is the application? Application is a process running on a software that is an application running on a system, and the system is operating system, and that operating system is running on a hardware, and that is in a given location in a data center or whatever, and that we called as cloud. So it kicked off with that 2008-ish time when Professor Satya Mahadevan is a great guy. He was the Andrew file system writer, so it goes back to history of 25 years back, even from 2000. So we have the very, very powerful concept that was given by him, and all his students all over started spreading the word that, hey, the next edge is coming, edge is coming. But edge never came. It not never came, but came and came and came. It's still coming. So why that? Because the constrained resource is not easy. It is not like you can host it on a day and then put it like a data center, a hyperscale data center which is in the cloud. That doesn't work. So you have to put a small one. So if you put a VM cloudlet, then the question is, where is that cloudlet? It has to be close to the user. If it is close to the, how close to the user? So therefore, in terms of telecom, we call it as edge. I am talking of telecom. Why I am saying telecom edge is because you have the core. Core is the place where all networks come, and then you take a round trip from there. So if you want to run an application, you run an application in the cloud. Your access device, which is a mobile device or a handset or a laptop, you connect it to the local ISP. And then that ISP gives you an IP address connection to the application which is in the core. And there is a pipeline established between your device and the application where it can directly communicate, and that is through VPN. So essentially, you've got a VPN access to the data center which is in the cloud of an enterprise, or it could be in public cloud, wherever. So basically, earlier it was only voice, so we used to talk about SIP, session initiation, where you initiate a session and then you get a IP, then you connect to that and then you start conversing. It's like a telephone, plain old telephone. You lift the handle and then you call and then it rings and then you get the other ring. And so basically connectivity establishment is the first. Once you connect, then you can source the application, or you can talk, you can do video, you can do audio, you can do data, you can do all call completion, whether you call it call or you call it data call. So essentially edge computing requires that the computational power and the communication is close to, in the vicinity of the end user. In this case, end user, I mean the client. That is the device of the client who is trying to access the particular application. So with that, this gives you a picture that end to end, when we talk about what are the elements in the device, is the first element. Then it goes to from device either fixed network or wireless network. If it is fixed network, then it goes through the ISP, through the cable, through the DSL or whatever, or even the wireline, or even through cable, like your cable antenna which you apply. That means through that internet is applied. So you can get a broadband, or you go through the wireless. That means you go to the cell tower. So that is the user to network interface. So you have to first establish a UNI connectivity, and in the network they will establish you are you. That means your ID, your authentication, authorization, authentication, accounting, all that is provided. That is corrected. Then you get to the next level. So that is cell tower. Then you go to the backhaul. When you go, not backhaul, actually you go to the front haul, because these days you are connecting to the cell tower. If it is mobile communication, cell tower has got Ethernet over fiber. So they call it eCPRI. CPRI is common public radio interface, and eCPRI is Ethernet over fiber. So you have to have, that is packetization of all the sound and audio and video, data, media, whatever your encryption, decryption, all that will be routed in a serial way, and that will go to the next layer. And next layer is the, if it was cloud, then it would have gone to the core, and core to the cloud. If it is not core, if it is not cloud, it is edge. Then from here, front haul, it must go into the edge location, which could be a cloudlet, it could be edge data center, it could be one server, 10 server, up to 10 racks. One rack can occupy around 16 servers. And these days, what is the next step? Next innovation in edge, it's called serverless computing. You don't know where it is. You are getting some resource from somewhere, God only knows, and then you get it. That is the automation level that we are reaching. So edge computing, even though started with the Akamai spreading the caching as the server for all the internet access so that you can speed up, that was in 2013. So from 8 to 13, it was all, everybody was trying, and Akamai captured the market. They call it edge, and then immediately HC, as usual, Europeans are good at documenting. They started, no, we must have a document. It should be standardized. They started with the NFV, and then followed by MEC. That is, they call it as mobile edge computing, and then multi-edge computing, all that renaming and renaming. Ultimately, they decided that there is a reference architecture, a MEC architecture, and there is another architecture which is like OpenStack, like cloud architecture. Then they said, no, there is a gap between the cloud and the edge, so we need to fix it. And then they started moving to the edge computing. MEC was becoming complex, NFV was becoming complex, so they combined the two, that you can use NFV. Ultimately, what it means is that your infrastructure layer, which is the edge layer, has to be fast enough to respond. So application apart, the infrastructure, the dilemma was, where do we begin? If I start writing edge application, I don't have the infrastructure to run. And if I take an application which is already existing over cloud, I try to migrate, I have to disintegrate, I have to distribute it, and then I don't know where it is being accessed. So again, there is a confusion. So either you go bottom up or top down, both way you get into failure. Failure in the sense the challenges are so many that you will finally give up, because infrastructure providers say, hey, I can't give you, forget about it. So the only way it will succeed as usual is in the middle to up and middle to bottom. So that is where the APIs came in. And therefore, everybody started throwing edge API. Oh, here is my API. Why don't you use it? Now, the standardization is always, whether standardization is ahead of application, or application, or users are commercial people are always ahead. Standardization follows, because they will try something, they will make money out of it, and then they will say, oh, this should be my standard. But that is not my standard. It has to be universal standard. So there will be 2 mice and 3 mice will come and say, hey, Nokia will give me this, Ericsson will give me this, Reliance will give this, Bharti Airtel will give this. So we'll have to combine all that and then see where do we go. And then say that we are trying to adopt to the standard. Generally, standard has been falling behind. Today, it's no different. So edge computing, why is it now, to add to the misery? Edge is where? Next question is, where is it? So a telco guy will say, oh, edge is near edge and far edge. Near edge means near to the core. Far edge means more towards the user, and that means it could be at the cell tower. But you go to a cable provider, you say, no, it is to the head end. And you go to the newer guys, they will say, no, pole. I'll put a pole, Wi-Fi or something like MiFi or something, and then you can access from pole. So pole becomes the all over the road. If you are going to have a V2V, vehicle to vehicle or vehicle to infrastructure, it will be on the poles. So the pole can be edge. IoT fellow will say IoT gateway is the edge. Everything. And now to add to the misery, there is a satellite, LEO, GEO, MEO. Now they are going to say, no. Wait a minute. This is terrestrial. You can have a ground vehicle and you can have your edge defined on the road. But I am in the air taxi. So my edge will be at the top. It will be in the 100-kilometer range or 500-kilometer range above the air. So now there is a gas. Gas means ground, air, and space. Ground communication is terrestrial up to kilometer atmosphere. Then 1 to 10 kilometer, that is the low altitude platform. There you can put a maybe a what you call drone or something. 10 to 15 or 10 to 18, something like that kilometer. 10 to 18 is for the real commercial airspace. Nobody is allowed to do anything there. That is only commercial. Then 18 to 30 kilometers, that is called as upper. That is called high altitude platform. There the only the missiles and all these are used. So if you are doing a missile, then that is a UAV, unattended automation. So UAV. So for UAV, you need a separate power thrust and all that. So you need a whatever, like we do satellite launching with a solid propellant and liquid propellant with the stages and all that. Stage 1, stage 2, stage 3, something like that. But this is horizontal because we want to hit some enemy, or maybe we want to prevent something. So it's a defense application. So you can have that way, or if you go above that, it could be LEO, GEO, MEO. The Bharti Airtel is fighting for the LEO, the constellation, where you can say implement thousands of satellites, which will cover with the smallest satellite, it will cover a lot of area in the Indian subcontinent. Like example, we have NAVIC. NAVIC is a positioning system which is consisting of 4 or 5 satellites, and then combining them, and then along with that can be connected with, like we get if you take a cell phone, you get a location lat long, and lat long, how do you get it? That is because of the GS, what you call GPS. GPS is the global positioning system, which is at 36,000 kilometers. Either you can have a satellite which is at the 36,000 kilometers and a ground station can pick up, or your mobile phone can pick up, depending on how you have the receiver. That is the satellite receivers. You can, or somebody can coordinate, and cell tower can get it, and cell tower can coordinate with other cell tower and provide you your location. So that is called assisted GPS. So you can have a GPS in your cell phone similarly. So that is location based. So location based service is very important for edge computing because you get maps and all that. When you are driving, you have to, and plus example, if we are talking of an autonomous vehicle, as previous speaker spoke, then you have to have the lidar, radar, all that, which will take the picture, and then you have to process the picture, and at the edge itself, or you must have a model, or you must be able to offload it to infrastructure nearby in the vicinity of your poles or something, and then get the correct, accurate. You should see that a human is a human, and a dog is a dog, and a cat is a cat, and you don't hit them. You try to ensure that autonomous vehicle stops and then waits until the crossing passengers or whatever. So you have to detect online. So that means the map application. All these are requiring high performance computing, and you can't do a high performance computing on an edge, which is a constraint, power constraint, resource constraint. So you have to offload, or you have to do some modeling, AI ML applications you have to apply so that you are able to do V2V and vehicle to passenger, vehicle to infrastructure. You make sure that you are on the road, your car is driving at the center and not wavering around, causing accidents and all that. So these are all part of the edge computing. So every time when we talk about it, the dilemma is, hey, should I do the infrastructure? Should I do the application? So bottom line is, you need to have standardization, and that is the one which is hitting the hardest, because you cannot standardize. We have tried in IEEE to standardize. So we propose something, And then the proposal keeps changing because every year there is a new application. So the onboarding becomes difficult. An application can be onboarded only if you know how the resources are abstracted and what are they referred to as, and how do you, like radio resource is different from a compute resource, from a storage resource, from a networking resource. So what are the create? If I say create an app, what does it require? It creates a VM, it requires a container, it requires a bare metal, we don't know. And depending on the application, if we already have something, so what it means is infrastructure has to be available for any application to really make sense. And therefore, the dilemma is very simply resolved. You need to have infrastructure. Now that is where the standardization comes, and that is where Kubernetes has taken over, because most of the people these days, whether it's the cloud, whether in the edge, everybody wants a small footprint, so they provide a container, and container can be managed, lifecycle can be managed using Kubernetes. Therefore, Kubernetes-based implementation has become the de facto standard. Like it or not, that's the standard. It is following that in most of the cases. And so when standards can't be adopted, then you have to go with the de facto standard. So Kubernetes containers are the main, and then VM is alternate, and the physical bare metal is third. And now the serverless computing is taking over, and or it will come. It is not taking over. It will come, which will be used as a means, so that you don't care whether it's a VM or a container. I want this much resource. I want compute which has a power of this, maybe whatever the definition. I'm not coming to definition because then Amazon has its own definition, Google has its definition. Everybody powered with 2 gigahertz or 4 gigahertz, whether it's instruction set architecture, or how the fetch and the executes are happening, whether it is 1 millisecond, 1 nanosecond, and is it parallel processing? So whether it has a GPU, whether it is FPGA, there are so many elements in the infrastructure that you will get lost. But the best thing is, if you have something Kubernetes infrastructure, then I can write, because when you have a Kubernetes infrastructure, what it guarantees is you don't have to manage the versioning and all that. You can have application which can be modified, systems can be versioned, and versions are important because without that you cannot really you cannot upgrade it, update it. So software, when you talk about hardware, you talk about you have to update, you have to upgrade, you have to be able to maintain, and lifespan of a software is approximately 10 years, even though we take depreciation in 5 years. Same way for hardware, it is around 3 to 5 years, but we take 3 to 4 years. You can use your double decline, whatever balance sheet you do, but essentially that means you have to be able to replace them, and when you replace it, then the migrate by the time technology moves ahead. So therefore the update, upgrade, update, all these are important, and therefore the versioning is important. So what I will put is onboarding of an application on an infrastructure is possible provided you have the cloudlet or a Kubernetes based infrastructure, which is footprint is low, VM, which is footprint is low, or you've got a serverless computing so that you can have an API, whether it is MEC based, that is multi-edge computing, or you are based on the cloud native and cloud application principles. All that is possible, and therefore, of course, Edge has to have a catalog of applications that are available so that you can choose the application. So you have to onboard. Once you are onboarded, then you test it, and the service can be tested for that it is going properly. And of course, applications have to be rewritten in a new way these days. Everybody wants to make sure that applications are written. Yes, I'm closing. So the applications are taken care for distributed and cloud native writing in cloud. So therefore, you have to rewrite the applications as the migration to newer application comes. Now it can be 100 containers, one application per container. It can be multiple application per container, or maybe side container. So various ways of doing it. And ultimately, at the end of the day, what we need to do is we have to make sure that edge computing is able to provide to India whatever we have got, our digital transformation, operation transformation, knowledge transformation, and that will enable us to be able to use this edge computing in a better way. And I believe that standards are there, but they are not the best, but application always moves ahead of the infrastructure, but infrastructure is one which has to be modular, and that is what is being provided. I think with that, I will leave everything for the Q&A session, and we can talk about it later. And thank you very much, and ధన్యవాదాలు to everyone.
Thank you, Mr. Prakash.
So thank you very much for that. Appreciate.
Thank you very much, Mr. Prakash. Just readily accepted our invitation and yes, obliged us. Thank you. Mr. Vishal, please introduce Mr. Seshu Venkata.
Sure. So Mr. Seshu has 2 decades of okay, I think there's an echo, no issues. So Mr. Seshu has 2 decades of IT industry experience across multiple domains: telecom, energy, high tech, healthcare, consumer, banking and financial services, covering product development, enterprise application development, and infrastructure management. He worked in Europe for about a decade, developing state-of-art mobile technology solutions like SMS, MMS, mobile internet, etc., with leading telecom companies. Currently working in Wipro as global head for Virtua Desk, cloud technology-based solution that redefines future workplaces. Sorry. He's also confirmed as fellow distinguished member for technical staff at Wipro, which elite architecture community that drives future technology direction of Wipro. He'll be taking us through the application and data security on the cloud.
Thank you to the FTCCI leadership team and Dr. Gautam Mahapatra for actually providing detailed insights on state-of-the-art work that is happening here and under his leadership, and also Dr. Prakash Garu. So today, as Vishal mentioned, I will be talking about the application and data security in the cloud. But I'll start with, I'm talking about modernization of the applications in the context of edge and 5G technologies, and then associated security risks and how do we mitigate them. Hope you're able to see my screen.
Yeah, it's visible. Yes.
So I'll be rushing a bit in the interest of the time, and of course, Q&A we can take. So I'll be covering about the 5G and edge technology evolution and how it is impacting the application architecture, and then followed by the associated security risks that are coming with this new technology architecture and how do we mitigate them. These are the topics that I will cover. As Gautam and Prakash have mentioned, the application architecture goes through a cyclical nature. Right? So initially we started with centralized infrastructure and applications through mainframes in the 1960s, followed by distributed applications with the client-server applications in the 80s. And then in 2000s, the cloud and mobile-based applications that were coming in, where a lot of dynamic content is being created through the mobile devices, is being processed and accessed from the cloud. And then in 2020s, again, we are getting back to the distributed architecture. The key technologies that are driving this disruption, again, if you look at it, for every 2 years, we are seeing, a disruption. So this time, the disruption is being, in the previous cycle, the disruption was driven by the cloud and, the mobile technologies advancements. So this time, it is about edge and 5G advances. So just to give some numbers, by 2025, about 152,000 plus IoT devices will be added to or will be connected with the internet every minute, cumulatively generating about 75 zettabytes of data. That is about 1 million petabytes of data. Okay. So this essentially would disrupt the current cloud applications. Because the cloud, first of all, it will be extremely difficult to pump so much of data to the cloud, and then, creating and managing such a huge amount of data in one central location is going to be a humongous activity. So this is where, it's going to, there is a dire need to change our application architecture, where we need to distribute one, we cannot keep sending the petabytes of data to the cloud from all over the world. Rather, we need to have the cloud coming close to the data where the data is actually being generated. Okay? So that is where the 5G is just coming in the right time, where it is going to provide high speed, reliable network connectivity, so that so much of data can be moved from the devices. There could be IoT devices, there could be end user devices. The data can be transmitted from these millions of devices close to the edge network, and then backhaul the traffic back to the cloud with certain amount of processing happening on the edge. So this is where I think 5G is promising about 100x speed and 10x lower latency and 1000x capacity compared to the today's 4G speeds. So as Gautam sir mentioned, today, right, we are going through a revolution here, in the digital revolution. The data is the new oil. Organizations who have efficient infrastructure application frameworks that can store, consume, and analyze the data, give them business insights, are going to have a competitive edge. They will be able to develop better products. They will be able to deliver better services. The companies who can accumulate and process huge amount of data. When we talk about, let's say, take the simple examples, right? Like, for example, Redbus is a startup from this part of the world. So they are able to process the data of every single customer. They keep giving the data of their bus, when it is starting, right? When it is reaching the bus stop, and they will be able to alert them when the bus is reaching their destination. It's going to call them. This is where actually they are continuously tracking huge amount of data processing and using that information to deliver a better service to their customers. And those are the companies that are going to thrive. So if you look at 5G from an evolution perspective, so it's almost from in the last 20 years it has gone far. So we started off with analog communication, and then with 2G, right? The focus was more on just text and SMS plus voice communication. With 3G, the emphasis was on increasing the data rates. With 4G, the emphasis was on actually giving a broadband like experience from the mobiles. And with 5G, I think there are three core pillars. They call it enhanced mobile broadband, where the bandwidth can go up to 1 gigabyte per second, and massive data transmission, on the machine connectivity, and then high reliability and low latency. So these capabilities will help to implement the new use cases. So if across the industries. Okay. So the new use cases are like, could be human to human use cases, or human to machine use cases, or machine to machine use cases. So the human to human use cases are like, virtual reality, augmented reality cases where just people can, collaborate remotely. Either it could be a meeting, or it could be, a video, gaming or interactive gaming, etc. People sitting across thousands of miles, so they can have that, interactive experiences for, their meetings or gaming experience, etc. So it's going to generate huge amount of data, through and also the video calling, virtual meetings, etc. And then, the video to machine, ultra high definition video, like, watching the use cases like the Netflix, of the world, right? Where you can have high definition content, interactive TV use cases, and then machine to machine use cases, like, the video monitoring surveillance, where the devices capture high resolution data, the data is processed, and use cases can be identification of, traffic patterns, identification of, the criminals, right? A lot of use cases can be built, where the use cases are machine to machine. Huge amount of data is created and being processed. These are the use cases that will be benefited by extreme mobile, or enhanced mobile broadband. And then the massive scale communication, where you have the variables, where you have millions of variables, generating huge amount of data that is being processed. Again, as Gautam, mentioned, where this information can be processed by government agencies to identify any pandemics, etc. Right, and healthcare monitoring, providing remote healthcare, especially for countries like India. Still, our health facilities are, far from, the Western world. So if you have to be at par with them, rather than it will be extremely difficult to increase the number of doctors, number of hospitals, but we can leverage the technology like where we can deliver variables and then put intermediate, edge computing machines that can actually process the data, and then only whenever an action is required, we go to the remote doctors who can take action. So those are the kind of use cases that can be built. Similarly, the autonomous vehicles is another use case for the massive scale communication, where the devices, millions of devices, they communicate with each other. To enhance the when we talk about the automotive use cases, traffic management, autonomous vehicles, congestion control, a lot of those use cases, can be realized using the massive scale communication capability of the 5G. And then ultra reliable low latency service, this can be used in the areas of public safety, remote surgery, again, in a vehicle to pedestrian use cases, again, autonomous vehicles, etc. And then, industrial automation. These are the use cases that can be built. So, the key differences between the cloud and edge computing, because, if you have to leverage this 5G capabilities, right, where you have millions of devices, generating huge amount of data, right? The existing cloud-based application architecture is not sufficient. So we have to move to, edge computing, where the data is, and in the cloud, all data is transmitted and processed on the cloud. And then data is stored in the cloud, in the cloud, probably just end result is sent back to, outcomes are sent back to the endpoints. Whereas in the edge computing, the data is processed at the edge, and, the data is, when the outcomes are sent to end users or the, endpoints, and also, the data is stored. So, the benefits of why we need to process the data at the edge, right? There's a massive, with these millions of devices, they are going to put a massive amount of data. This is where we need to have the data close to, the users, and then process it so that we can have actually fast response times back to the, use cases of the users. Again, if you have to achieve, real-time and ultra real-time performance, like remote surgery kind of use cases or public safety kind of use cases, again, we need to have the processing close to the, end users or the end services. Of course, we can also use this to deliver the contextual services based on the user location, based on the user condition. We can deliver contextual based services. So all these capabilities require, it's not only just, in the previous era, right? When we are moving the applications from on-prem to cloud, it's only just, refactoring of the applications to just use the cloud services. Now, this is to development of new capabilities. We can add, at least 10x more capabilities to the applications, to the services with these capabilities. So some of these examples are, dynamic content delivery, where you can actually dynamically contextualize the content for the end users. For example, right, taking the, user feedback while somebody is watching a TV or a show or a newspaper, right, in the polls, etc. Augmented and virtual reality, which can be used for learning and development. Now the digital universities concept is coming up. So if you, in the past, if it is theoretical subjects like arts and science, people can actually learn remotely. But if it is a technical education, people have to go to universities or polytechnics. Now with this technology, even, people in the remote villages, they can have access to the latest technology using AR, VR technologies. They can actually do the experiments, do the labs. And similarly, intensive computational assistance, for use cases like, autonomous vehicles. So video streaming analytics, again, how, we have TV on demand, we can actually avoid redundant video transmissions with edge computing, where you can cache the data and, transmit, so that we can avoid transmission, IoT use cases, connected vehicles, cognitive assistance, is another, interesting use case, where you can actually use less skilled people to do the, highly skilled job, with the cognitive assistance technologies. Thereby, right, you can address the skill gap that is actually plugging various industries today. That is actually hindering the adoption of the technology. So, these are the different applications like the drones, which can be used from security to smart farming, healthcare, from remote health monitoring to robotic surgery, emergency services detection, and actions to prevent the damage to the property and the lives, autonomous vehicles, smart cities, smart agriculture, the manufacturing, smart manufacturing, supply chain logistics, the mobile offices, entertainment. These are all the use cases that can get immensely benefited with this technology. So, with mobile office concept, in Wipro, using the virtual desk platform, we are able to help implement, the remote working, to hundreds of thousands of employees during the pandemic in a very short period of time. So where, we virtualize the laptop desktop workload to the nearest cloud location, so that the desktop will be close to the customers to avoid the latency issues. But we are able to monitor them from central locations. Just this is one use case of how we are able to leverage, and also leveraging 4G, 5G technologies to effectively deliver Teams and WebEx kind of streaming technologies from the virtual desktops running on the cloud. Where we are able to enable, implement, BYOD, or help the organization set up BYOD without compromising on the security aspects. So while the 5G and edge actually brings in a lot of these new use cases and flexibility, it also brings in some of the security threats at the edge level. The physical security of the edge devices itself is a major concern, and authentication and access, because we are going to have the user data, or the business data on the edge devices. They can be stolen, they can be accessed, because on the data center, you have a strong physical security, perimeter security, which is lacking in the edge. And then when you are expanding the perimeter, so you're expanding the threat surface, and the data management, data storage, data backups, the data protection becomes a challenge on the edge. And then IoT devices, MTM protocols, again, because of the thin footprint in computing, capabilities that they have a lot of protocol vulnerabilities. Again, ingestion of rogue hardware, software at the edge, can actually compromise the entire system, not only the edge. And then physical device tampering, compromised hardware, software, it can impact the businesses and the services. Similarly, on the network also, since we are providing access to the cloud data, cloud applications to the millions of endpoint, the IoT devices, and then to the thousands of edge devices, we are increasing the perimeter of defense to the network and to the cloud. And then Wi-Fi, and then the network security vulnerabilities, routing attacks. And then there are a lot of, there are standards the common standards are not there at the moment, for device management, especially for managing, this quite a good number of unstructured devices, because this technology is evolving. And then, privacy issues, we are going to transmit, sensitive information, through these devices back to the data centers or to the edge. Coming to the cloud, the threats are edge connectivity, security, identity access management, data security, at rest and transit, application access management, and device attacks. I think these are the threats, at these layers of this new, new world. I'll quickly cover what are the mitigation models. This is a complex and comprehensive subject, but in the interest of the time, just I'll cover the key topics. On the edge, we need to enhance the physical security, access control and surveillance mechanisms to ensure the security of the devices, at the edge, using the motion sensors, security cameras, which are integrated with intrusion detection, intrusion prevention technologies. Second thing is selection of edge devices. We have to be careful. So we need to select the devices from trusted manufacturers and who are following, minimum security standards and compliances and industry standards to the respective industries. And then, we need to control the edge configurations and operations from a central IT operation. So we need to bring in tools and technologies, that can be used to centrally manage and monitor the edge infrastructure. And then we also need to establish audit procedures to control the data and application hosting in the edge, what data we can save, and who who can access the data. And we need to regularly monitor all the activity on the edge logs. When I say this monitoring cannot be eyeball monitoring or manual monitoring, again, it has to be done in an automated manner. There are a lot of AI and ML based monitoring tools are available that continuously monitor the activity logs and alerts, in case if it detects any aberration or malicious activity. And then operating systems need to be hardened at regular intervals, like we manage our laptops, desktops, and the cloud infrastructure. And then we need to monitor the unusual behavior, like high network traffic, high power consumption, or high compute consumption even on the edge. Coming to the network, in addition to applying all the standard, cloud security technologies, so we need to implement, the zero trust security that is picking up momentum now, at all layers, like the network, devices, users, applications. And then we also need to implement, so that that there is no implicit access. We should avoid using the technologies like VPN, just that grants implicit access from point A to point B. So every data, every application, right, every device, every network need to be authenticated for every transaction. This is what we need to implement to enhance the security posture. And then we also need to put automation and analytics in place, for continuous, activity monitoring and complete visibility of the network applications and data, and then identify any malicious activity or to identify any compromised asset, so that they can be immediately quarantined and isolated. And then access, we need to implement role-based access management through privileged access management tools. Gone are the days where you can have high privileged accounts, just you give access to only a select number of employees. So we cannot trust anybody, right? It has to be need-based access point in time. So that means if somebody need access to do a specific activity, access to that individual to be provisioned to do only that activity at that point in time. Soon as he completes that activity, access should be revoked. So these are the kind of tools and processes that we need to put in place, so that we can reap the benefits of advances of all these technologies without putting the business at risk. Okay. I think with this, I will stop here. Of course, I will share the slides and open to take any questions.
Thank you, Shashivaru. It's an excellent presentation. So very useful. Now the floor is open for question answers. Please come forward with your questions. Tom Karan.
Yeah, it was a very good presentation on both the application architecture by Prakash Garu and subsequently all of the threat mitigation measures and safety measures that need to be taken at the edge. My question is, where does zero trust security stand in all of this? And I mean, there are like a lot of vendors these days. Everybody is talking about zero trust. How does zero trust and edge correlate and coexist?
Certainly. For example, right, when we have applications running on cloud, who will need access to what components of those applications, right? So that can be defined, using the CASB kind of technologies. Just this is one element of the zero trust. Okay. Similarly, from when it comes to the access management. Okay. So whether we are accessing if a sensor has to send the data to an edge computer, or if an edge computer has to send the data to an application and running on the cloud. So we should not be using a standard VPN based technologies. Rather it has to be an authentication, a token based authentication that need to be granted at a very granular level, so that we are not doing instead of if you look at the historical security models are using IP blacklisting or IP whitelisting or VPNs, etc. Right? So we need to move away from those technologies where access is enabled only to the required modules in an edge to the required applications, right, on the cloud.
Thank you, sir.
I would like to add a couple of things in this. First thing, you remember, zero trust question is what level? Underlay level, overlay level? Because to establish any application, you need an underlay. And if the problem is in the infrastructure, what can the application do? That's why you do a tunnel. But even a tunnel is not end to end, right? It has to go from hop to hop. Sometimes, because even a simple cell, if you take a cell, you have one hop from your cell to the cell tower, and another hop from cell tower to the gateway to the application. So you got what you call bearer, which needs to be stuck together to create whatever the application and whatever the protocol you are using. So it could be at application layer, session layer, it could be at the infrastructure layer. So it is a layered approach. So the question is, it's not like firewall is stopped, means everything is stopped. You have to look at multiple layers, and not only that, man in the middle attacks are there, internal attacks are there, external attacks are there. So you have to defend even against them. So you do, example, you try to book a ticket in Indian Railway, you will know you will be knocked out within time, because they don't want you. Their rush is so much that they have to time you out. So the timeout concept is very important. Two-phase authentication. So these are elements of zero trust. Zero trust is nothing but a coined term by the HC, zero trust group, who just 3-4 years back realized that there needs to be a security. So a security does exist. At what layer? Right? Do you want to do transport layer security? Where do you want to draw the line? That is it. So there is a standard, but what is practical is what is practical. And we have seen two-phase authentication is at least the minimum most we do. And then we make sure that there is no malign or some hacker hacking out. And so any security patches are there, they're up to date, whether it's on the OS, whether it's on the transport layer, or whether it's at the device layer. So all needs to be end-to-end protection required. And that is zero trust. So you don't have to go by the word, but go by the actual what is applied in a given context. And those who run with that, they know, like UPI, yes, what a fantastic protection they have got. You cannot match that anywhere. We can talk big, but it is what is deployed that is the key. And I think India is very good at it. Yeah, I will stop there. Thank you.
So I guess there's a question by Mr. B.M. Rao. He has mentioned that in the chat. He says, who maintains the edge computing nodes?
Right. So, so right now, it is mostly the enterprises, right, who are, deploying this edge computing infrastructure in their the remote factories or remote facilities. But eventually, there will be use cases where the public services, they want to deploy that. Probably they can be managed by service providers. Today, I like the way Amazon and Google, they are offering the centralized cloud services. Probably we'll see the edge services also coming from the leading service providers. in a way, I mean, even if you look at right and just changing so fast. So at least 2 years ago, Amazon, or Google, probably Amazon they had early, but Microsoft, they didn't have a big data centers in India. Now they are expanding the data centers, across multiple locations. So eventually, right, it will most likely it will be,
I can mute, I cannot unmute.
right, and then also the telcos will also play a role in that. Right now, it is more of private enterprises maintaining edge, computers or edge data centers for their purposes. But eventually, it will be the business will be commoditized. Telcos and hopefully CSPs might play a role there as well, and possibly the governments.
Yeah, I would like to add, Prakash here.
Yeah.
Who maintains the edge node? Who is the provider? So if it is a telco-based edge, then it is the telco. If it is a ISP-based, then it is the ISP. If it is a cable provider, cable-based. If it is application provider, they can only do application level security, right? They can only provide application node and distributions. So they generally, if it's on-prem, then it's your own. Okay, so you can do everything on your own. But it is distributed across multiple. Like it could be that I am connecting to a T-Mobile phone to a Indian equipment, and that is in let's say Mumbai, or it is in Hyderabad data center. So the question is, I am using something which is remote, right? Now that has a that has got a IMSI. That means there is a subscriber ID. That subscriber ID is validated by who? By the T-Mobile, which is there. Maybe it is a German or US, and then that provider has an agreement, or that provider allows this roaming. So there is a roaming agreement. So there is another. So the edge, where is the edge, decides who the node owner is responsible. Period. The node owner can be anybody. It can be combination thereof, because you may have application which is running. Part of the application is running in Hyderabad, and part is running in Mumbai, part is running in London. How do you know? So the data privacy, that is the reason all this data privacy act, why are we running after it? Because we want to make sure that who is the fiduciary of the data, and who is the principal, who is user, and in between how the data is being processed at what node. Is it at the edge node? Is it at the cloud node? Is it combination of edge node? Whether it's one application, it is multiple application. Is it a blanket you get, or you get per application you get? So there are so many things that a node provider has to take care. They are just one in many. So they have to fit into the entire node network of nodes, of edges and cloud to be able to deliver. So who owns that depends on who is providing that service for that specific use case.
Thank you, sir. Thank you. Thank you.
Once you're on mute.
So that seems to be end of the question answers. I invite Bala to propose vote of thanks.
Thank you, Mohan Garu. And first of all, I would like to say that the panel of speakers have really set the overall context of the application modernization powered by 5G and Edge. I would like to start thanking Dr. Gautam Mahapatra, who has really provided the overall context of how these new trends are really transforming the marketplace and also creating new use cases. He also extracted the information associated to the quantum beyond whatever we are trying to say today. And I would like to thank Prakash Ramchandran, who spoke on the app first or infra first dilemma of the edge computing. Truly, this is a dilemma in the today's enterprise context, and I believe his talk really opened up the thoughts how we need to unlock this dilemma and try to foresee the new use cases to be realized. His deeper understanding about the overall edge layers, like the mobile edge or the infra edge and other things, and the way he has constructed his particular speech really resonated very well and helped us to understand and have a deeper understanding how application and infra related scenarios can be unlocked. Thank you, Prakash. And I would like to thank Dr. Seshu Venkata, who has really deepened the thoughts with providing us the information associated to the evolution of the 5G, evolution of the edge, and how it is really translating to today's context. Over and above, he has also deepened the thoughts how the application scenarios are changing and how we need to really look from the application and data security from the cloud, 5G, and edge context. There are a lot of mitigation areas what we need to really look. When we try to expand the portfolio of use cases across the industry, there is an immense number of security challenges we encounter. So it is very, very critical and important for all of us to start looking into those particular dimensions and see how we try to avoid those things by putting up a right mitigation plan. I believe the three speakers who have given that entire context of the 5G and edge really helping us to focus upon how we start developing the application modernization and also take the benefit of low latency of the 5G networks and also take the advantage of the distributed nature of the edge computing so that applications truly take the power of this particular technologies and provide a reliable experience for all of our users. And further to that, I would like to thank the entire FTCCI leadership who has instrumental in and constantly motivating the ICT committee to do this kind of a technical talks and bring new technologies into the limelight and orient many of us. I would like to thank the entire ICT committee chaired by Mohan Raidu, who is spearheading these initiatives on a constant basis and trying to give some unique initiatives, which is helping the institution members and also the users of the FTCCI. With that note, I would like to finally thank Vishal, who was very, very instrumental in ensuring this particular thing is seamlessly done. Thank you, Vishal, for anchoring the discussion and introducing the speakers. Thank you all. And with that, now we close this particular session.
Thank you. Thank you very much.
Thank you, everyone.
Thank you, everyone. Thank you very much, sir.
Thank you.